In this video, we look at structure 1.1.2, which includes a quick look at the kinetic molecular theory of solids, liquids, and gases. We'll look at the states of matter, we look at the use of state symbols, and also the changes of state. So we'll start by looking at the particle models of a solid, liquid, and gas. So from left to right, we have a solid, in the middle we have our liquid, and on the right we have our gas. So according to the kinetic molecular theory, or the KMT, all substances are made up of particles. These particles are in constant straight line motion. They have elastic collisions, which means there's no loss in kinetic energy when two particles collide. And the absolute temperature of the substances is directly proportional to the kinetic energy of the particles. So for a solid, the particles are all closely packed together. For a liquid, the particles are still quite close together, but there's a little bit of space, which shows the particles are able to move. And in a gas, we can see that there's a lot more space between the particles. So next we look at some properties, which are the flow, can they be compressed, their shape, and their volume. So solids cannot flow, they cannot be compressed, they have a fixed shape and a fixed volume. Liquids can flow but cannot be compressed. They don't have a fixed shape, instead they take the same shape as the bottom of the container that they're in. But they do have a fixed volume. Gases can flow and can be compressed. They don't have a fixed shape, instead they take the same shape as the shape of the container that they're in. And they don't have a fixed volume. So next we look at the changes of state, which are melting, evaporation and boiling, condensation, freezing, sublimation, and deposition. So let's start with melting, which is a change of state from solid to liquid, S to L. Then we have evaporation and boiling, which is the change of state from liquid to a gas, or from L to G. Even though both are for the change of state from liquid to gas, they are not the same. Boiling tends to occur at a specific point, which is termed the boiling point of a substance. And evaporation can occur at lower temperatures than boiling. Next we have condensation, which is gas to liquid, or G to L. And then we have freezing, which is liquid to solid, or L to S. So these are the changes of state that we are fairly familiar with in our everyday lives. Which leaves two changes of state which are not so common, sublimation and deposition. Sublimation is the change of state from a solid directly to a gas, so from S to G, with no liquid state. And deposition is the change of state from gas directly to a solid, again with no liquid state. Although these changes of state are less common, you do need to be familiar with those, so make sure you remember to include sublimation and deposition when learning your changes of state. So next we look at state symbols. So state symbols represent the state that a reactant or product is in a chemical reaction. So the state symbols we'll use are S, which is for solid, L, which is for liquid, G, which is for gas, and then AQ, which is for a substance in an aqueous solution. So here we have an example chemical reaction in which sodium reacts with chlorine to form sodium chloride. In terms of state symbols, we have an S for sodium, G for chlorine, and an S for sodium chloride. This means that the sodium is a solid, the chlorine is a gas, and the sodium chloride is a solid. In the next example, we have the reaction between methane and oxygen to produce carbon dioxide and water. So in terms of state symbols, we have G for methane, which is a gas, the same for oxygen, the same for carbon dioxide, and then we have L for water, which is a liquid. And the last example, we have the reaction between lithium and water to produce lithium hydroxide and hydrogen gas. So we have S for lithium, which is a solid, we have L for water, which is a liquid, we have AQ for lithium hydroxide, which means that it is dissolved in solution, so it's an aqueous solution. And then we have G for hydrogen, which means it's a gas. So this chemical reaction has all 4 state symbols. We can also use state symbols to represent physical processes. For example, here we have H2OS, which is solid water or ice, and that's forming liquid water, and this process is known as melting. Another example is the sublimation of iodine, where iodine as a solid changes directly to iodine as a gas. So here we have the state symbols changing from S directly to G. So state symbols can be used in both chemical reactions, and also they can be used to represent physical changes such as melting or sublimation.